Naji here, welcome to my YouTube channel. So we are continuing our discussion with regression, and in this video we are going to discuss about multiple linear regression. So in our last videos we have discussed about simple linear regression and its advantages and how to calculate the best fit line and all those things we have discussed. So in multilinear regression, okay, it is used to predict the outcome of a variable based on the value of two or more variables. Okay, so when we compare with the simple linear regression, we know that we will have only one independent variable and one dependent variable. So when we come to MLR, we will have two or more independent variables will be there, and we will have only one dependent variable. And definitely say we can say it as a extension of linear regression. So this is an example. Okay, here we can see we are going to predict the selling price, and selling price is the dependent variable. And we can see there are 7 independent features are there. One is car name, year, kilometers driven, fuel type, seller type, transmission, and owner. Okay, so all these details will contribute to the selling price. Okay, for example, we can consider two car names. One is maybe we can consider the Swift, and we can consider the Alto 800. So if we consider these two model names only, okay, forget about like all these other independent features. Okay, so if you are considering only Swift and Alto 800, we know that the selling prices of Swift is higher than the Alto 800, right? But if other features are coming into the picture, for example, years, kilometers driven, and fuel type, all those things, then we cannot say that the value of the Swift is always greater than the Alto 800, because consider here Alto 800 is a make of year is 2017 and Swift is 2014. Okay, and consider it is a latest one. Consider the Alto is like 2024. I think they have stopped the 800, but still, if the year is 2024 and the kilometers driven is 0, and the transmission is maybe instead of automatic, instead of manual, if it is automatic, then in this scenario the value of Alto may be greater than Swift, right? So all those things will contribute to the selling price. Okay, so this kind of a problem can be solved using the MLR or multilinear regression. Okay, so this is the example of it. And mathematically we can say that y is equal to beta 0, beta 1x, beta 2x, and etc. beta p and xp. Okay, so this is similar to y is equal to mx plus c. Okay, as I mentioned earlier, it's actually the extension of simple linear regression. So in simple linear regression, we will have simply only these two terms, right? Beta 0 plus beta 1 into x1, right? Because in that case, simply we have only one independent feature. So here we will have maybe n independent feature. So it just expanded the simple linear regression. So by using this example, we can rewrite this as beta 0, okay, and beta 1 into car name, okay, beta 2 into year, beta 3 into kilometers driven, beta 4 into fuel type, and beta 5 into selling price, plus beta 6 into transmission, and beta 7 into owner. Then we will be, by calculating all those things, we will get the selling price. So in multilinear regression, what happens is that this will trying to, our algorithm will trying to figure out beta 1, beta 0, beta 1 until beta 7, okay, which will contribute minimum error. Okay, so that is the goal of the simple linear, multilinear regression. So we can use similar to simple linear regression, the same method we will be using maybe gradient descendant to figure out the best fit plane. Okay, so here in simple linear regression we will be using we will be like trying to figure out a best fit line, right? But here, when we come to the multiple linear regression, multilinear regression, it is actually using a plane. Okay, a plane, a best fit, instead of best fit line, we will be trying to figure out a best fit plane. Okay. So there is a spell mistake here, sir. I will correct that. So I will show you that. Just a second. So consider this example. Okay. Here a 3D representation of it. Okay. So here we have maybe x1 and x2 is there. x1 and x2, and we will have a y values here. Okay. So this is actually a plane. I believe everybody can see this. This is not a simple line. So this is a plane. Okay. So we will only 3-dimensional we can represent it, but when we have like more features, its size will be very, I mean, its plane will be very huge. I mean, number will be very high. We cannot represent it more than 3-dimensional. Okay, maybe it will be like n-dimensional. So here it is very clear. Here we are trying to figure out, using the gradient descendant, we are trying to figure out the best fit plane, something like this. Okay. Yep. Okay, so I believe I have explained about multilinear regression, and yeah, it's simply an extension of simple linear regression. So that is all about in this video. Please do like and subscribe. Have a nice day. Bye bye.